welcome back. We are coming back to our next talk. We get to talk about Kubernetes some more, but we're looking at it from the other side of the house. This time, we're going to be hearing about app development on Kubernetes, the patterns, the tools, and the practices. And Kaslin Fields is going to be joining us to share all about this journey. I'm very excited to hear. Take it away, Kaslin.
Hello, and thank you for having me. Very excited to be here, and I'm super excited to be going after Whitney, whose talk gave a wonderful overview of what Kubernetes is and a lot of the tools and how they're relevant to different roles. So in this one, we're going to dive deeper into application development. And I also want to mention that I am a big fan of sketch notes, so that is another reason you should go back and watch that talk if you missed it. So first off, hello, I am Kaslin Fields, and I am a developer advocate at Google Cloud, once I get all of my things in order. So I'm a developer advocate at Google Cloud, where I focus on Google Kubernetes Engine as well as open source Kubernetes. I'm an ambassador for the Cloud Native Computing Foundation. I'm also a member of the Contribex special interest group. So that's the special interest group for contributor experience in the open source Kubernetes project. I focus on cloud native, DevOps, and especially Kubernetes topics. And I'd like to illustrate things as well. So you can see this slide as one that I've illustrated, but I don't have much of that in my presentation today, unfortunately. So today I'm going to be talking about app dev with Kubernetes. And we're going to start by breaking down the problem and understanding really what that means. And then we're going to talk about 3 patterns that I commonly see organizations using with regard to how Kubernetes adoption affects their app dev teams. So first, to break down the problem, we need to know what is the question that we're trying to answer. As an advocate for Google Cloud, and especially Kubernetes users in general, I interact with a lot of companies adopting Kubernetes. And almost every single one of them is asking me this question. The words vary, but the point is always the same. How are the lives of my application developers going to change as we adopt Kubernetes? I call this the Kubernetes app dev experience question, and it has 3 basic parts. First, the organization is adopting a tool, Kubernetes. They're asking about a specific audience, people in the role of app developer. And what they want to know is how the tool, Kubernetes, is going to affect the day-to-day tasks of the folks in the app dev role. And always keep in mind that a business's goal is ultimately to deliver value to their own users. So the overarching frame that this question fits into is some approximation of the software delivery process. The business wants to run apps that are critical to them. Sometimes that's apps they built, sometimes they're apps they got from elsewhere, but ultimately the tools, roles, and tasks involved are all trying to accomplish the goal of running those important applications. And so to answer this question, we really need to get to the root of it, to really talk about the software delivery pipeline and where all of these things fit into it. So let's start by diving a little deeper into the software delivery process. This is a diagram that we sometimes use at Google Cloud to talk about the tools we have available that enable each stage of the software delivery process. These tools aren't important. I'm not going to be diving into any particular one of them or anything. I just like how this diagram illustrates my point, and you'll see what I mean. So this goes from writing code to get the application to the point where you're getting the applications running in production and also monitoring those applications. And so these processes roughly align with 2 broad roles: developers who write and maintain app code, and operations professionals who run those applications in production and other environments. We've talked before in this conference, if you saw some of the earlier talks, Aaron in particular mentioned how these roles aren't always the best way to describe what's actually happening here, I guess is a good way to say it. There are all kinds of specific roles that fall in this spectrum of tasks that need to be accomplished. And where one ends and another begins varies a lot from one company to another. It's kind of like a gradient, like I have here. It's hard to tell where one role might end and another begin. But what does this have to do with app dev experience on Kubernetes? The traditional realm of app developers is pretty solidly on the orange side of our gradient, as I have it in our slides today. The app devs are in charge of writing and maintaining app code. And to do so, they use tools like integrated development environments and source control tools, and that's pretty standard wherever you go. But today, we'll also be talking about Kubernetes. And if you'll notice, Kubernetes on our chart is pretty far toward the operations side of the house. This is why the question of what does the app developer experience look like with Kubernetes is actually kind of hard to answer. Traditionally, Kubernetes has been created by and for operations professionals. So often when this question comes up, the folks who have been the deepest in the Kubernetes ecosystem, those who helped to create Kubernetes, tend to respond with, well, developers shouldn't really care about Kubernetes at all. But is that really true? It certainly kind of looks that way from the chart, right? But understanding this, of course, brings us to DevOps. So what is DevOps? I used this definition from Google Cloud's definition of DevOps because I think it illustrates this really nicely. It says that DevOps is the organizational and cultural movement, so that means that it affects how your roles relate to the ownership of tasks that need doing, and it aims to increase software delivery velocity. That's kind of a dev side kind of thing. You can see how that relates to developers. Improve service reliability. That sounds kind of like site reliability engineering, which is kind of more on the ops side of the spectrum. And most importantly, DevOps is about building shared ownership among software stakeholders. So you might not have known it, but what you asked was a DevOps question. What this means is that even though Kubernetes was designed by and for operations professionals for the most part, due to this shift toward more shared ownership models using the DevOps model, the answer to how is my app developer experience going to change with Kubernetes is maybe. Kubernetes may affect your app developers' day-to-day lives, but as with any good question in tech, the real answer is it depends. I hope the folks in the room said that along with me. It depends on what parts of this process your app developers have ownership of. Ultimately, the tasks that your app devs are expected to own will determine what tools they're going to need to use. So for the rest of this talk, I'm going to explore the 3 most common patterns I see organizations adopting with regard to app development with Kubernetes. Each of these patterns introduces a bit more DevOps-y style ownership into app developers' lives. Many organizations I speak to are on a path where they move from pattern 1 toward pattern 3 over time. Most large organizations will probably have spots within their orgs that implement each one of these patterns. There's no one right answer to how your app developer experience should be as you adopt Kubernetes. It'll depend on how you want to distribute tasks and ownership of the software delivery process among the roles in your organization. We are focused on application developers as the only role that we're really focusing in on today. So I'll explore the tasks and tools your organization might assign to your application developers in each of these patterns. So let's dive in. To start, let's talk about what I call the traditional local development pattern. In traditional local development, app devs own tasks up to the point where code is checked in and ready to be handed off to teams that will run the code in whatever environments it needs to be run in. The delivery artifact for these developers is source code. They write code, check it into source control, and that's pretty much where their ownership ends. That code will still need to be built and deployed onto hardware, but those responsibilities aren't owned by the average developer. This is how most organizations have traditionally scoped application development type roles. And the tools that these developers typically use haven't changed too terribly much over the last couple of decades or so, at least. Your application developers will need an integrated development environment to do their coding in. They'll need source control to collaboratively work on large code bases. They'll need to learn some sort of programming language, or maybe a few. And they'll need to get familiar with libraries, both public and private code libraries that they'll be using to build the applications that your business needs. So the traditional local development pattern keeps you pretty solidly on the left side of our ownership spectrum of the software delivery process. This is the type of development role that most people are thinking about if you ask them a Kubernetes app developer experience question and they come back with app devs shouldn't care about Kubernetes at all. In this pattern, with the way the world has kind of traditionally been, that's been true. Kubernetes was designed as a tool for folks who run code in various environments. It has nothing to do with writing pure application code. So if that's where your ownership ends, then you might not really interact with Kubernetes at all, and it might not affect your daily life. So developers in this pattern would typically complete their application code and hand it off to some other team, which might containerize it and run it in Kubernetes, because Kubernetes does require that app code be packaged in containers. But asking some other team that didn't write the code to package that code in a container can be kind of rough. The whole idea of containers is that the application code and all those binaries and libraries that it needs are packaged up together. And who knows those dependencies better than the app dev team that wrote the thing? So that brings us to pattern 2, development in containers. In the development in containers pattern, application developers take on the additional responsibility of packaging their application code along with any and all dependencies into containers. The delivery artifact of your app dev teams shifts from source code to container images or definitions. A container image is something like a binary file. So if you are familiar with writing code and you'll compile your code up into a binary file, that's kind of what container images are to containers. It's the compiled form of the package containing your application and its dependencies that can then be run as a container. The application developers in organizations that have adopted this pattern need some additional tools. They'll still need IDEs, source control, and a solid understanding of their required programming languages, but they'll also need containerization tooling. The tools to perform containerization at scale really started to be publicly available and to gain popularity starting in 2014. So the developer tools in this space are generally less than a decade old, though they're, of course, built on older concepts. The most common tool folks have heard of is, of course, Docker. I like to say that Docker is a usability company. They didn't invent containers, but they did invent the usability tooling that has led to containers' current popularity. If you're using Docker, then you'll need to write Docker files to define how your containers should be built. Then you can use the docker build command of the Docker CLI to compile that into a container image. You could also potentially create your container image with an open source project called Cloud Native Build Packs. Cloud Native Build Packs is an open source project of the Cloud Native Computing Foundation that allows you to, and I'm just going to quote from their webpage, it allows you to transform your application source code into images that can run on any cloud. Still quoting from their docs, Build Packs provide framework and runtime support for applications. They examine your apps to determine all the dependencies it needs and configure them appropriately to run on any cloud. So basically, this open source project provides a bit more automation in converting more traditional applications into containers. These, of course, aren't your only options, but there are a few that I'm aware of and have played around with. So the development in containers pattern moves your app dev team's ownership a little farther toward the ops side of the diagram. And it's not that these pieces become wholly owned by your app dev teams, but you're leaning into this DevOps style shared ownership model. Operations type teams will probably still have responsibilities around configuration and ownership of these tools as well. This pattern does start to get into changes to your application developer experience when you're adopting Kubernetes. but it doesn't directly have anything to do with Kubernetes itself. Organizations that don't use Kubernetes could see benefits from adopting development in containers because containers themselves provide nice benefits as a packaging and isolation mechanism for your applications. But if you're sitting there going, yeah, but is that really a Kubernetes app dev experience? Don't they need to know about Kubernetes itself? Then pattern 3 may be for you. In pattern 3, we explore an even more involved approach, developing directly on Kubernetes. So in this pattern, application developers own the tasks of patterns 1 and 2, completing code check-ins and containerizing their application code, and they pick up the additional responsibility of understanding Kubernetes enough to define how their containerized applications should run on Kubernetes by writing declarative YAML manifests for Kubernetes objects, like we were talking about in Whitney's talk. So if you didn't check that out, definitely go back and check that one out. So these Kubernetes manifests are key to the declarative nature of Kubernetes that Whitney also did a great job of explaining. So they describe the container as well as details about how that container should be run in an environment. Things like storage and networking configurations are built into the API of objects provided by Kubernetes. In pattern 2, some form of more OPSI team would take the containers that the app dev teams wrote and then write these Kubernetes YAML files to describe how the apps should be run in Kubernetes. But in this pattern, we're once again asking the folks who know the application the best to put that knowledge to use by defining exactly how those applications should run in Kubernetes. The tools for these developers will grow once again. In addition to all the tools of patterns 1 and 2, these devs also need things like a Kubernetes environment to test and develop in. This could be a local environment via Minikube, which is an open source component of the Kubernetes project. Minikube is great because it basically uses a local virtual machine to run a single node Kubernetes cluster locally. So you can try things out on Kubernetes without connecting to a cluster of separate hardware. However, it can also be fairly resource intensive. I know it's slowed down some of my machines in the past to run Minikube clusters on them. So sometimes that can be difficult if you're working with an older piece of hardware or a piece of hardware that doesn't have a lot of CPU and memory available to it. And also, it's not 100% representative of a real cluster because it only has a single node. So that sometimes does give some limitations. But for the most part, Minikube is a great option for development. I know a lot of businesses create separate clusters or at least a separate namespace within a cluster for development work. In this case, you would be using the internet to connect to a cluster, either that your company runs on on-prem hardware somewhere or in a cloud provider. I mean, technically, if you bought the server rack from the Nooks, you could set this up on there and have a Kubernetes cluster running right in your house on your very own island. But I mean, why would you do that when you could have more fossils in your house? But maybe that's just me. Anyway, I also want to mention that the Cloud Native Computing Foundation offers a certification for developers with this level of ownership. The Certified Kubernetes Application Developer exam is a hands-on exam that tests your knowledge of writing manifests to run applications on Kubernetes. It's basically the YAML engineer cert. So if you are a YAML engineer and you want to become a certified YAML engineer, you might want to check that out. So the developing directly on Kubernetes pattern moves your app dev's team ownership even farther toward the ops side of our diagram. Your application developers are taking on additional responsibilities that have traditionally been in the ops kind of sphere of ownership. But again, this is a shared ownership model where these pieces likely still need operations teams ownership as well. This shared ownership model where devs use Kubernetes directly means your app developers will likely need to gain knowledge about how these environments work. They may not have had to worry before about enterprise scale storage or networking considerations. So they may need to learn a bit about those things in the frame of Kubernetes. I want to caution that Kubernetes, as we've mentioned here a couple of times, is a large, complex tool that's meant to provide tooling for management and abstraction of the underlying infrastructure. So you may want to be careful to make sure that your devs are learning about the bits of the Kubernetes system that they most need to know about, which Whitney really nicely went over in her session where she talked about the different Kubernetes objects and how they relate to different roles within an organization. So check that out. There's plenty of more ops-oriented stuff in Kubernetes that your average app dev might not really need to know about. So that's the 3 most common patterns that I see businesses today implementing with regard to their app development on Kubernetes. Which one is right for you depends on how you want to distribute tasks and ownership to the various roles in your organization. If you want to keep app devs focused on code and have another team handle basically everything else, that's pattern 1, talking about the wall that Aaron mentioned in his talk earlier. It's probably come up a few times. If you want your app devs to start containerizing their applications to package them with their dependencies and make them easier for other teams to run on a variety of systems, that's pattern 2, where you have app devs take over containerization. And if you want your developers to own everything from how the app works to its packaging to how it's going to be run in a Kubernetes environment, then pattern 3 is for you. Definitely take a deeper look at the tools that I mentioned here, like build packs and Minikube and the CKAD, the Certified Kubernetes Application Developer thing, if you want to learn more. And that's it. And I hope we have time for questions. Thanks for joining me for the last talk of Deserted Island DevOps.
Thank you so much, Kaslin. That was great.
It's always an honor to be one of the speakers that ends the conference on such a good note too, like being able to cover like the application side of stuff, as we've been kind of focusing more on ops. And I love that you mentioned build packs. Like that's always been one of the projects that's been on my list to get started with. Like I do come from the app background, but I do more ops SRE now. And I'm like, let's find time to play around with build packs one of these days to be more of an app developer. I'm
definitely still learning.
At least we learn together out in the open, so that's great. One of the questions that we have coming in from Twitch as you were sharing the 3 tiers of models, is there a 4th way of doing this where they can actually admin the Kubernetes cluster themselves?
Oof. I mean, I'm sure that somebody out there is doing it. And it sounds kind of rough for them because that sounds like a really broad array of technology and like array of skills that you're going to have to develop and own. So I would not envy anyone in that position, but I'm sure it could be done. I'm not going to recommend it in a talk as a 4th model.
Yeah, we have someone asking like that they're doing it now, so they were just kind of asking, I guess, how possible it is. But a lot of it it depends, kind of like that classic, like, what is your organization? I said those words, yes, Heidi.
It depends.
It depends.
It's what works for your organization and the scale and the growth that you're having and your developer experience. And
the resources that you have and the time you have to make something work. And yeah, it depends.
Headcount, time, and money.
Yep. So we have another...
Large organizations, I wouldn't want to do that.
Yeah. We have another question in the chat. How does one kick off build packs? I fancy myself smarter than the average bear with Docker files, but I can't get over the hill of adding yet another abstraction to the stack.
Interesting. So I've been playing around with it a bit myself, as I said, and there's a command line tool called packs. The way this works for me is maybe a bit different than than the average bear would do on their own, because I've been playing with like Google Cloud's integrations with it, because as we mentioned, the concept of build packs is to be able to run it on whatever cloud. And so Google Cloud announced support for this project in 2020. So I've been looking into what our cloud's integrations are with it. So the way that I do this is we have a IDE plugin called Cloud Code, and I have Visual Studio Code as my regular IDE. And so I can use an example application of some sort, and then I set it up in Cloud Code to use Google Cloud Build as its building tool. And as an option there, it can use build packs to take your application and like I mentioned earlier, build packs kind of has some smarts to detect what the dependencies of your application are, and then it kind of puts together the Docker file for you, is kind of how I think about it. I don't know if other people want to share their opinions, but so you take the application minus Docker file and put it into this build process, and build packs kind of figures out what it needs to become a container image and build it into a container image. So that's how it works for me.
Nice. I'm not too familiar with it, so I have not much to say, but we do have folks chiming in the chat that they are using the Heroku ones and the Patica ones. So there seems to be some other alternatives. So make sure to like research around.
Kind of depends on what kinds of environments you're using, which kind of seems counterintuitive when you think about it. But anyway.
Yeah, I thought the whole point was it didn't depend on which environment. Never mind, containers. They're more complicated than we thought, and clouds aren't actually neutral. And next you will tell me that there is no Santa Claus. So.
Uh-oh, we can't go there.
No, we can't go there. That would be crushing.